Okay, thank you. I'm going to be talking about an effort we completed this year at the FCC, and I want to emphasize it represents for us the start of a long-term program. We viewed it as an exploratory effort. It's something that's going to evolve over time, focused on trying to understand better how broadband performs in the United States from the consumer perspective initially, and perhaps in other areas over the long term. This is our standard disclaimer. I wish to absolve the FCC from blame for anything I might say. The views are my own and not those of the agency. Okay. The FCC has a long history. I think most of you probably have heard of the Federal Communications Commission. It has a long history in overseeing and acquiring data on the legacy PSTN. But in that, broadband networks have not been addressed in any rigorous sense, and the internet has not been a general focus of these study efforts. So over the history of the FCC, as the networks have evolved, as technology has evolved, we've actually developed a fairly complex schema by which we acquire data in terms of the health of the general public switch telephone network, but this has not been done in any way for broadband. That started to change. I think the most significant thing recently was that in 1996, the Telecommunications Act was rewritten, and Section 706 of that Act required an annual report on the availability of advanced telecommunications services to all Americans. The term advanced telecommunications services I always find interesting, because today most of us take broadband technology and internet service as not advanced but as necessary. But that act resulted for the first time in information specific on the deployment of broadband technology. This is done on a yearly basis now. There's a form called Form 477 that goes out to all ISPs, and they're required under federal law to report back to the FCC on the deployment of broadband technology, and that's been expanded and adapted over time, so the FCC has a fairly good understanding of the capital impact of deploying broadband technology. More recently, the FCC released the National Broadband Plan in March 2010, and that plan for the first time proposed that we ought to find out more about performance measurements of broadband services delivered to the consumer household. That was stimulated by a number of different areas. There was a report in England from their regulatory agency, Ofcom, on broadband service as delivered by ISPs within England. There have been a number of, I'll say, casual or anecdotal reports that have been put out by various organizations or companies detailing what they believe to be the state of the broadband consumer nation in the United States. And we've actually referenced in some of our reports some of that work, which at the time, going back to March 2010, suggested that the advertised rates to consumers were sometimes overly optimistic. Some of the reports that we had identified suggested that carriers delivered only 50% of the advertised rates, and certainly this was the measured result in England. So the work that we began to undertake evolved out of the National Broadband Plan. This was really the first effort by the Commission to do this. We haven't really looked, as I said, hard at broadband performance rates. We sought, therefore, a high level of voluntary participation. We had a number of discussions about how to go forward with this, and we thought it would be better to do it in an open, transparent fashion and work with a broader range of interests as possible, rather than do this wholly within the Commission. So we approached a number of ISPs, we approached academia, consumer groups, we put out public notices regarding our intent regarding this, and these interactions, as they evolved, shaped this initial study. And I'll emphasize the broadband measurement work is still in progress. It's still ongoing at the present time. We're continuing some discussions with ISPs and others in terms of future evolution of the plan. So again, we view this as the very formative and exploratory start of a program. So what did we actually do? We enlisted the cooperation of 13 ISPs that cover 86% of the U.S. population. So with working with the internet service providers that voluntarily participate in this program, we covered 86% of the U.S. Broadband consumers in the United States. We formed an ad hoc group of people that then consisted of vendors, trade groups, universities, and consumer groups, as well as ISPs. Over time, we had an informal term for this group of people. We called it the collaborative. And in the beginning, when I was asked, well, what does the collaborative mean? What does it do? And I said, well, if you're a Star Trek fan, I always thought of it as the Borg, but minus the good intent. But over time, because this was a very eclectic group of people, a lot of distrust beginning, but over time, working over a period of 6 to 8 months, we actually did form a level of trust and a common objective among the participants. We reached an agreement on what we were going to measure and how to measure it, and I should have a slide on this. Unfortunately, I don't, but what the measurement technique involved was sending out routers to each volunteer consumer participant. Each router was programmed to do a set of measurements on a periodic basis. They were installed in the consumer's household. There were a number of network servers in 8 different cities across the United States to provide reference points for these test nodes in the consumer's house to test against, and this data was periodically collected during the course of a day and over many days, and formed the basis for our report. We eventually enrolled 9,000 consumers as participants, so we shipped out 9,000 routers to consumer households. 6,800 of them were active during the report period. We based our formal report on the month of March 2011, and a total of 9,000 were active over the entire data collection period. We have a data repository from February through June of this year that constitute 9,000 consumer participants, and we issued a formal report on August 2nd of this year. I'm not going to go in depth into the report. It's available on our website, and I would urge those of you who are interested to take a look there. But what we released as part of the report was a main section describing major conclusions and major results, a full technical appendix describing the test schema, the methodology, the survey approach, various aspects of each test. We've also provided a spreadsheet of standard statistical measures of all tests for all ISPs and speed tiers measured. We released the entire data set we collected for March, which was a normalized data set. And one of the advantages we had working with ISPs that we were able to document for each participant what their theoretical provision service rate was, as well as their geolocation. This data set was presented with anomalies removed. It represents 4 billion data elements from over 100 million tests that were performed during the month of March. We have what we call a raw data set. The boxes started up in February, and we extracted February through June, and that's available on our website also. That does not have the provisioned rates. It has any anomalies when boxes didn't work or other effects are in that data set, but that was made available. And as I said, we geocoded the data, and that was recently put up on our website, and that information is available at the URL I have listed here. These are the tests that we agreed upon among all the participants. Sustained download, sustained upload, burst download and upload, various latency tests, videos test designed to mimic video streaming, tests designed to mimic a VoIP capability, the aggregate bytes up and down that a box saw during the course of a scheduled period of time. And some of these are emphasized in the report. All of them are captured in the data, and all of them are described in the technical appendix. Okay. We had a lot of discussion about what type of data we were going to collect, and we rapidly agreed on not to collect personally identifiable information. So we just didn't want to go down that path. That means that names and addresses of people were not retained by the FCC. Geotagging, when it was done in an aggregate level to ensure privacy. So, for example, we could have resolved down to a census block as one approach, but anybody who's familiar with census blocks knows that there are some census blocks that only one person, one family occupies, and so we have a level of aggregation that obscures individuals. The other thing we agreed to do was we weren't going to focus on observing what types of applications people are using. So we're basically focused on the transport level and the reliability and performance characteristics associated with the transport level, and no information associated with how that transport capability is being used within an individual household. Some of the highlights and perhaps the most interesting result is that what we found is that most ISPs deliver close to advertised rates even during peak hours. Now, shortly before we issued our report, there were a number of magazine articles indicating that this wasn't the case, and even after, I guess, our report came out, we had some dialogues with certain groups that this result was not correct. However, nobody has seriously attacked the study that we did. And on a personal level, I believe the results are accurate and differ dramatically from what we saw in Europe for several reasons. Perhaps most significantly is our carriers tend to advertise a specific rate, where in, say, England, they advertise a service and you take whatever rate you're capable of running at. So they tend, in that environment, the opportunity to emphasize optimistic or to advertise optimistically is much greater. Here there's more of a service contract paradigm, and I think most ISPs actually try to deliver reasonably close to what they're advertising. If that 100% line you see there is the 100% advertised service line, those rates are normalized against that line, and most of the carriers are above 80% even during peak hours. There's a different view of the same data, and some carriers don't deliver what they're promising. And we saw a lot of variability between carriers in terms of the engineering rules that they apply. Performance varies by ISPs. One of the things you can pick out in the data is that the ISPs, not surprisingly, each have their individual performance objectives, and a large number of their service tiers group within those performance objectives. Occasionally you'll find a service tier, a rate that's off from that, but you can see that each ISP tends to have some defined engineering rules that their people operate against, and most of the services from that carrier are grouped within those service objectives. Not everything was always friendly and collegial. One of the biggest battles we had in this discussion was a cable telco fight over how you define speeds. The cable companies advertise and offer something called burst speed, which is a queuing technique providing a temporary speed increase from what we found less than 15 seconds. So, and we had a great deal of argument over whether we wanted to include that as a rate. And we did a truly Solomon-like decision. We did split the baby, and we offered up both speeds. So if you read our report, we have both what we call a sustained speed, which is a long-term duration speed, as well as a burst speed. We basically measured over a period of 30 seconds after a startup interval, and the first 5 seconds of that 30-second interval was taken as the burst speed, and the final 5 seconds of that 30-second interval was taken as a metric for the sustained speed. We do believe that for certain types of services, the cable industry has a valid argument that for certain types of applications, burst speed can be meaningful, and therefore we agreed to include it. But it can't generally be applied to DSL where you're running at the sync rate or the maximum rate already, and its value is marginal to fiber, where each subscriber has potentially available anywhere from 37 megabits to 75 megabits of provisioned bandwidth. So it really is a cable industry offering at this time. We did include the results. We looked, this particular graph is not in our report, but it's a normalized impact of burst speed. So in effect, what I'm showing here is the performance improvement over sustained speed that burst makes, and you can see that most of the impact of burst speed can be seen between 6 and 12 megabits per second from what we measured in the cable industry, and declines as the higher you go. The effect drops off in terms of impact on speed. Its highest rate is, its highest impact is around 6 to 8 megabits. Another thing we saw in the study is that we are still an asymmetric environment today. Upload speeds do not appear to be congested among any of the ISPs that we looked at. Download speed is the limiting factor and continues to be the limiting factor in the industry. We looked at reliability. Packet loss rate was generally less than 1%, and there was some correlation between peak periods and packet loss, with higher loss occurring, of course, during peak hours. But even during peak periods, most companies' packet loss rate was less than 0.4%, and the worst case seen during our formal study month of March was 0.8%. We did see some results. We worked, as I said, collaboratively with a couple of universities. Georgia Tech was permitted to have access to some of this data. They chose to use data from an earlier period, and during that period they noted that one ISP seemed to have numbers in excess of 1% packet loss. And I'll note that talking to a number of people in the industry, 1% packet loss is also cited as a video threshold requirement. Above that, and video streaming becomes somewhat unreliable. Another result we saw was web page downloading. We downloaded the top 10 websites and measured the time required to do that. What we started to see was that at higher rates, you start to have diminished comparative performance. So if you go from, say, 1.5 to 3 megabits, you'll see a 100% increase in performance. But as you go up and up and up, various factors start to limit the performance increase. And one of the discussions we have, and we're hoping to do more work on this, is, is this a canary in a coal mine? Does the capabilities of the consumer in terms of the network architecture serving the consumer, their household environment, does performance top out after 10 megabits? We're at an interesting point in time, actually. If you only go back to about 1995, you had, one color choice in the broadband spectrum. Every service provider offered you like one service rate. And now providers have as many as 10 rates that they're managing. Some of those are being grandfathered, some of those are being introduced, some of those are proverbial cash cows, but you're at a point in time at which a consumer can get up to 100 megabits per second, perhaps even higher in certain areas. And the question becomes, do they derive any benefit from that? I will compliment the ISPs that they've made a remarkable investment in technology to reach those rates, but are we looking holistically in terms of the benefit to the end user from going to higher rates? And we're still looking at the issues associated, whether it's latency-induced, server loading, household platform limitations. We had some anecdotal discussions again with Georgia Tech indicating they've seen some similar performance issues as they've looked at the higher rates. We've also had some discussions, interestingly, with Ofcom and others suggesting that globally the full benefits of higher line rates are not being realized at present. And this is important. Every year, OECD comes out with a report showing the United States is 17th or 18th or 19th or 20th in terms of broadband, and I think we're starting to ask, is this in the context of a meaningful, discussion? Are we, if we're delivering 100% of what we advertise, and other companies are delivering 50% of what they advertise, and even if everybody was delivering 100% of what they advertise, consumers can't get that performance level yet in the internet. What are the performance metrics we should be looking at then? So I think that higher speeds may challenge industry to examine performance bottlenecks, and certainly it'll challenge the Commission to look at performance metrics in terms of what's meaningful. Another thing we tried to do, and I emphasized again, this is, anybody who's done anything exploratory, we don't have a rigid schema we were working against, and we had a lot of things we tried. Some of the more dismal ones we haven't reported on, but one of the things we tried to do was ask industry luminaries, generally chief technologists or CEOs of other companies, how much speed is needed for what. And as the commission, one of the things I've appreciated, I haven't been at the commission all my life, but you do have access. You're viewed as a government authority that is not biased against any specific company. So you do have incredible access to going to a Google or a Netflix or an AT&T or Verizon or a Cisco or a Juniper and getting somebody in a position of authority to ask them some interesting questions. So we took advantage of that and surveyed ISPs and industry leaders for advice on just how much speed is needed and what's driving the need for speed. We did get what we'll call a mean opinion, but the variance was really infinite. A lot of ISPs urge consideration of application need and household size, emphasize complexity and need to encourage an upward evolution. So the people who are selling the service basically saying you really need to encourage, and by the way, this is in line with commission policy. We have a broadband plan foresees a time at which the average consumer should have access to 100 megabits per second, and the industry that's making the capital investment is saying we should encourage that evolution. Industry advice separate from that range from buy as much as you can, to needs of video are currently less than 5 megabits per second and will possibly decrease. The more interesting observations that I took away from these discussions, one, trying to explain to the consumer that it's a moving target and they need to understand that. And I think anybody who's lived in this industry, thinking back to where we started in the mid-90s and where we are today, understands that the high-tech performance levels of yesteryear are archaic by today's standards. Some people argued that higher performance speeds are not presently realizable by the consumer end-to-end due to technical issues associated with the network. Some argued you really do need a content delivery network to solve some of these issues. Another argument is that cloud computing is going to significantly change the way people use the internet, and that will continue to challenge demand for upload speeds. Many people pointed out that latency is important. Latency is one of the metrics we did measure, and argued that there are many factors, not the least of which is human factors, that suggest latency needs to be tracked and is a negative impact on the network. One company pointed out, don't forget about DNS resolution speeds, also a limiting factor, and reliability of the connection is important. All things we tried to measure within the study, and I think all things we'll focus on in the long term. Unknowns in the study, we started measuring the performance of the ISP. So what we're measuring is the performance from somebody's basement to the first major peering point. We're not measuring the total internet. Some people are doing that. There's some work going on in France looking at, for example, in-home contributions. Certainly, we think some of the current reporting on under-delivery by ISPs has more to do with household effects than what the ISPs are delivering from what we're currently seeing. And we're also not measuring the contribution of other network elements, so the effects of bottlenecks in the network, investment content that application or content providers are making or not making, end-to-end latency effects are not covered in this study. The study itself, although an initial effort, has already had some impact. One of the things that's occurred is that the FCC has released its rules on an open internet. One of them focuses on transparency. We've already told internet service providers that they must disclose typical performance, service performance to consumers. So we've told internet service providers they have an obligation to give some reasonable estimate of service performance to the consumer. And I'll go back. I've been involved in a lot of discussions over the past year and a half. If I go back a year and a half ago, we had discussions on the fact that it's a best effort service. So we had these dialogues where I said, well, we can't promise anything because it's a best effort service. And I would go, well, if I buy 10 megabits, what can you promise me? And they say, well, nothing. Well, I said, well, what if I buy your 100 megabit service at 5 times the cost? What can you promise me? And they would say, well, nothing. So we've gone from those sort of stupid dialogues to a much more realistic understanding that these are engineered networks. They have performance objectives. Engineers get annoyed when the performance objectives go south. If they go south too far, their upper management gets annoyed, and everybody gets annoyed. Sometimes people even get fired. So these are networks that are designed to perform within statistical boundaries, and that these boundaries can be reported to the consumer as a reasonable expectation of performance. We saw that on a report. We saw that in the metrics that we accumulated ISP to ISP. We could guess at specific service objectives that one ISP had versus another ISP. So we know this is a realistic request to internet service providers. We're also looking at continuing this effort in a number of different ways. Since we already have 9,000 boxes out there, we've already committed to do this study at least one more time. So we'll probably in March redo the study. We'll probably have to replenish some of our panelists, but the ongoing cost of this is a lot lower than initial setup. We're also starting to work with the ISPs on automating this as a measurement process. Long term, we would like to build a measurement technology directly into the cable modems, the DSL modems, and the fiber optic modems that are distributed to the population. So we believe that this is a capability that can be built into the equipment and provide an opportunity over time for regular service reporting by ISPs in terms of the quality of the service they're delivering to the end user. We don't know where that's going to take us, but we're starting dialogues now with ISPs on that, whether we keep the same measurement criteria, whether we evolve it. We're already talking about possible linking up to different standards groups that are already doing similar work. This is a very formative part of the process. The other thing we want to do working with the ISPs, we want to take the people out of it. The first effort was very manually intensive. We had to vet each panelist, each volunteer in terms of their provision rate, in terms of their location data. That's all can be automated. That's part of this process. This is not going to happen within the next year, but it's a long-term effort that we're undertaking discussion with the ISPs. We're still looking at doing something similar in the mobile environment. It's much more complex for obvious reasons, and we're having discussions with a number of companies in terms of what the opportunities are there. Another thing we're going to try to address over the following year is to take a look at the rural environment. 13 ISPs constitute about 85% of the nation. You have 1,000 ISPs constituting the next 15%. We're trying to see if we can get some qualifications associated with those 1,000 ISPs. It's a different challenge than doing 13. You can't apply the same methodology, the same survey approach. We're starting to think we might want to do this on a case study basis to pick sort of rural proxies that we can use to work with. That's still being debated. Another thing we'd like to talk about is other end-to-end measurement points. Can we get better data on what's happening within the household? Can we get better data on critical other parts of the network? And these are all up for discussion at the present time. Okay, as I said, this is an initial effort. It's been very beneficial over the past year. I think the report we did was very well received by a broad segment of industry. More importantly, it's emboldened the Commission in terms of looking at expanding the work, continuing it, and trying to understand how we take those numbers and bring them back into policy objectives. Thank you.
Bill Norton, NANOG member. Thanks a lot for the presentation. It was really great to see some data coming from the FCC like this. One of the things internet engineers love to argue about is measurement methodology. So I was just curious if you had a lot of pushback or heated discussions about the way that one would perform those various measurements you listed.
We had pushback. And that's why, in fact, we didn't want to do this by ourselves, because if we were going to get shot, we wanted to be in a large crowd of people and just make it a more complex target. So we actually outreached to MIT and Georgia Tech, and we worked with the ISPs who brought almost as many engineers as lawyers to the table, and to be fair to the internet service providers, they really did a wonderful job on this. They brought their A team. We had access to their engineers. We started with a schema that a company called Sam Knows, who was our contractor on this, had developed for Ofcom in England, but we adapted it based upon the discussion. So we originally envisioned this as a 6-month project and less collaborative with the industry. And after some initial discussions that we saw an opportunity to work with the industry, we changed the methodology. So instead of doing this much like Ofcom did, we decided to do it embracing industry, which was one of the objectives of the broadband plan. That doubled the length time because suddenly we had 13 companies we had to work with in addition to the academics and in addition to consumer groups. We had suggestions from MIT on how to change one of the things MIT brought into the pot. They were interested in latency under load. So if you look at it's not brought out in the report, formal report, it is in the data. There's a latency in the load metric that we've got in there. This burst speed versus sustained speed occupied months of discussion. It was a big split within the industry, and like I said, if the FCC was Solomon, you'd have the story ending with a baby split in half because that was our solution to the problem. Each got what they wanted, and there was some interesting discussion, and I'm not claiming we have the right methodology now. So I'm saying long term, we want to look at evolving the methodology. Some of the participants have said they'd like to take this into a standards body. We have no objections to that. And so we're in a very formative discussion in terms of the long-term plan. Yes? Oh, I'm sorry.
Lorenzo Coliti, Google. So as we run out of IPv4 addresses, I can see ISPs responding in different ways. Are you planning to measure the impact on users of IPv4 exhaustion on their broadband connections in the sense, for example, are you planning to measure the adoption of IPv6 and or the adoption of large-scale NAT?
Not necessarily. Well, recognize that this is an evolving effort, so I wouldn't rule it out, but initial focus was on service performance. However, there is a group that the FCC is chairing called the Technical Advisory Council. That's a group of outside industry experts, generally chief technology officers or other senior people from companies. Vince Cerf is representing Google on that committee. They identified IPv6 evolution as one of the critical issues the Commission should face. We're doing two things in that area. One is we're starting to work on a tracking process for IPv6 adoption. There's been some discussion that, especially from the ISPs, that the current metrics we're using don't really capture faithfully the adoption rates that are going on. And the other issue that they brought back to us was better government involvement in this issue. So I've done a lot of work in the past 4 or 5 months talking to the NTIA, which is the other major government stakeholder in this area. We've agreed to work collaboratively on this. In fact, we're trying to organize a workshop. We don't have a date for it yet that would focus on policy metrics for tracking IPv6 evolution, as well as a recount of lessons learned IPv6 Day is the broad objective. So we are starting to approach that issue from there, and how we would institutionalize it, I think, would be a longer-term question. So does that answer your question?
Kind of, yeah. Thanks.
Good afternoon. Good afternoon, Dan Ellis from Pentella Data. Do you have any recommendations for any of the other ISPs other than the 13 on how to possibly proceed with getting the information that the FCC is requiring, such as the realistic speed numbers? I mean, as of November, the FCC wants us to publish that information to the customers, but obviously you guys know the complexities of trying to...
Well, I mean, I can tell you first of all, we're not prescribing any specific way. So this is not do it my way or the highway. So what we've given, what I think as an engineer is a reasonable objective, okay? Give some reasonable expectation of the average service level that your customer should see. Okay. Now, then we've also gone on and said if you want to use something like what we did in Sam Knows, one, you can certainly roll your own because we've published the methodology. So if you want to do something like that and you want to make the investment, you can build your own. There are outside companies if you want to do that approach, Sam Knows being one of them, that you can contact to perform such a measurement. Or, as I said, you can use internal resources. So we started with a broad approach. As we get better guidance from industry, maybe we'll be able to refine that, but we tried not to make it onerous. So we gave options to a number of different companies. We also, by the way, if you're a very small company, we were suggesting that there's an out that if you're a very small company, you can point to one of the bigger guys and say, well, this is typical of performance for this technology. So,
one other question. Have you considered looking at any of the data from the CDNs that may be able to also give you performance data?
it's something, let me put this in my terms. It's something I'm interested in. And to do this, we've used a very voluntary process. So yeah, it's something I'd be interested in seeing. We're expecting to increase the dialogues we're having with broader interests over time.
Thank you.
Hi, Alain Fiocco, Cisco. Let me pile on a little bit on Lorenzo's comment. I'm glad that you guys are looking at IPv6 adoption metrics, those kind of things. But in the meantime, a number of service providers, a number of ISPs will or are deploying already carrier-grade NATs functionalities. Certainly in the mobile space, this is being used heavily, and people are sharing public IP addresses. Any plan to either measure or eventually publish oversubscription ratios, because this does have an impact on the end user experience?
The only thing I can say is what I've already said and has been reported on publicly. We're working with industry groups to develop metrics, templates that we could use to start tracking on a long-term basis adoption rates. I'm not claiming that we have anything finalized. I'm saying we're starting a process. Industry has suggested some things that they feel would be relevant towards that. And we're trying to do this with integrating the government agencies that have our stakeholders in this and working with industry. So is there anything immediately on the table? No. Are we starting to focus on moving in a direction where we have say a long-term metric? That's part of the goal, at least, that the TAC has recommended.
I guess my point is, in particular in the mobile industry, this is something that is heavily used. So if you start looking at the mobile industry,
this would cover mobile as well.
Hi, Alan Lewine, Comcast. The Measuring Broadband America is providing and analyzing metrics related to wireline connections.
Correct.
Are you looking at expanding the program into Wi-Fi, 3G, 4G, other non-wired connections?
We are looking to we're talking about the possibility of what we might be able to do in mobile. Mobile is much more complex for the reasons of the variability of the technology, the fact that people are moving around. We are probably going to do something this year. I'll just leave it as it's an area of interest. It's a question of whether we can engage on something that's practical, but we are looking at it. That's all I can really say.
So when you say mobile, does that include Wi-Fi?
No, the initial target would be wide area wireless networks.
Okay, thank you.
Any remaining questions? One more, good.
Hi, Dylan Green, Microsoft.
Yes.
Quick question about user experience. When you're running these tests, did the users report adverse impact to their normal experience?
The tests were designed to grab the pipe when the user wasn't doing anything, and when the user came online, if they exceeded a certain threshold, the test would cease. Statistically, we got enough data that we were transparent to the user and still able to acquire a ton of data. But the idea was we didn't want to get in front of the user. Another issue we had to take into account, which is an evolving issue, are bandwidth caps. Some of the tests, for example, download tests, are starting to run up against bandwidth caps, and we had to adjust the scheduling of the tests such that they wouldn't come close, they wouldn't have any impact, any significant impact on bandwidth caps.
Thank you.
Okay? All right, thank you very much.
Thanks.